So I think it's going to be a typical presentation. I'm not going to talk too much about steel, so don't run away. We start with a slide about circular economy, and I think I don't need to explain you what circular economy is. I think I'm not going to dwell on the slide, but the key point there, I think, is on the right corner. In the end, it's about economical benefit. And what I'm going to explain you today in the slides, in the presentation, is a little bit of comparison what's happening in another industry, another, I think, crucial industry in Europe. It's in the chemicals industry. I want to make some comparisons, see some similarities, what's happening there, and how they are going to be affected by the circular economy and sustainability. And these slides are basically based on a point of view which has been written by Accenture together with the European chemical industry last year. And I don't know if I can make a link available because there's a lot of data behind it. And of course, I'm going to summarize the data. And I don't want to fall asleep about the different details we have there. So basically, the outcome of the research we did, let me immediately tell you, go to the end, were two parts. First of all, I think, if you talk about circular economy and the chemicals industry, we're talking about how we can recirculate the molecules into the industrial loop value chain at different stages. And our research has shown that we believe that 63% of those molecules can be reused one way or another. The second point, though, I think is for me, even more important, and I think very similar to what we see in the steel industry, is that if we look at the chemical industry, including its downstream industries, its customers, you see that the impact they can have on environment, on energy consumption, is even much bigger. Just think about, if you look, for example, the comparison, the savings in energy the chemical industry could make on a yearly basis by optimizing its processes is estimated around 2%. If you ever look at R&D and suppose that the chemical industry would be, which they have done in the past already, would make it possible to insulate houses much better, the impact on the energy reduction or is far much bigger. And of course, I'm sure that in steel, we all can find similar loops and similar impacts on the downstream industries. And so I think that's a bit the message also we have here, is that we can focus on the first part in this presentation, but nevertheless, we should keep thinking about the innovation part and how that affects, in the end, the total energy consumption or reduction of energy consumption into the European industry. So, again, this is an example. Think about the biggest markets in chemicals industry, and one of those markets is the agriculture. And just look at how circular economy teams are really impacting the chemical industry. And just as an example, I got the same example for metals then, steel. Or I've seen the agenda, I think quite some presentations about the different impacts in steel. I'm not going to dwell on that neither. But this is for a good example in the chemicals industry. Think about agriculture. And think, for example, about the trend we see about natural fertilizer. It's a change in consumption pattern, product features, materials. So organic farming, going to be bias-based, less nitrogen, phosphorus, and so on. And in the end, it's going to lead to less demand. And that's, of course, a no-brainer. But if you think then, for example, about digital enabling sustainability, precision farming, for example, where farmers have the ability to really precisely determine where to use fertilizing, it's going to have an impact on less fertilizer. There's going to be more specialty fertilizers dedicated to what the farmer needs and requiring high performance. So you will have less demand, but indeed with a higher efficiency. So that's how circular economy and the downstream of the chemicals industry is impacting the chemicals industry itself. It's going to have an impact on demand. Steel industry, this is just an easy example. I think it's about the car industry and what we see about transport just take one example. For example, car sharing. There are figures indeed with car sharing is that, high utilization rate. Going to have more standardized cars probably. Material properties probably more durable. So you can expect a lower steel demand. think about autonomous cars. There you can expect that, a lot of question marks still though, is that in the beginning you will have probably stronger steel to take away a little bit maybe the discomfort of people. In the end, maybe again lighter steel, and maybe other materials. That's also the question mark then. So you see how circular economy teams are really impacting the industries, as well chemicals, also steel. But okay, let's go on to the, well, this is a slide, this presentation we also give to chemical industry, and I think what's important to mention is that in the steel industry, of course, the circular economy team is part of its process, is at the core. It's about scrap reuse. Whatever, if you talk about electrical arc furnace or you talk about blast furnaces, you have scrap reuse, and it's always at the center of the process. Or the reuse of slag, blast furnace slag. So this is a slide probably where in the chemical industry people are looking at like with big eyes. For you people here, this should be, of course, an easy one. So let's go to the core of the presentation. Is how we see 63% of the molecules being reused in one way or another in the chemical industry. And we define 5 loops. 5 loops. First loop is about renewable feedstock based on biomass. Second one is product reuse. The third one is about mechanical recycling. Fourth, chemical recycling, where really you go look for the precursor to start the process again. And the fifth one, which already was addressed with Mr. Eggert earlier on, is a whole CO2 discussion on how to try to capture that one. And so let's go into the first loop, which is all about renewable feedstock. Today, already 10% of the feedstock in chemicals is based on renewable feedstock, so it comes from biomass. It's fermentation of sugars, vegetable oil, and there are 2 extra benefits of reusing renewable feedstock. First of all, is that in the process of coming to that renewable feedstock, you need biomass. And basically, the natural process of photosynthesis is going to capture CO2, carbon dioxide. It's one advantage. Second advantage is also, in order to come from biomass to that feedstock, renewable feedstock, there's often less energy required than coming from naphtha gas to the other feedstock. But then again, it's also a bit of theory, because if you would really switch the complete feedstock in Europe into renewable feedstock, the whole Romania, a little bit more even, should be used as a harvesting area for biomass. Not talking about the energy, R&D, all other requirements you need for that. So it has certainly its limitations. We still believe that 11% of molecules we use can come via that circuit, that loop. Now for steel, we try to make on each slide a comparison with steel. You'll see often it's a little bit artificial. Well, here I think it's quite, easy. It's about reuse of scrap, it's about slag. I think it's one of the base processes in the steel industry. Now, let's go to the second loop. Okay, a bit slower at the left. Is about the reuse, product reuse. And we see today that a lot of parts can be reused in theory at least, can be reused in the chemical industry. And if you look today, I think today 50% of the chemical output ends on landfill. There's 44% which is then recycled, and there's only 5% which is being reused. And the example we have typically is reusable PET bottles. Maybe as an anecdote, I think 17 years ago or 15 years ago, I did my dissertation at the Ghent University, and it was about increasing temperature resistance in polyethylene naphthalate bottles in order to reuse them. Still not there yet. I think a lot of high ideas, big ideas, but basically it's not there yet. And one of the key things also, and this one, so going beyond reusable PET bottles. Yes, there are some examples in chemicals where you have like the barriers where they can be used. But in the end, in order to increase this one, there's going to be cooperation needed between the industry, between the end customer, and already a design. We should try to look at it, where we are and how we can really improve this one. In steel, I think it's one of the part of worldsteel association. There's also reuse possible. Steel wrappers, appliances. There are also other examples. There's an example, I think, about a bridge somewhere in the brochure of the World Steel Association, which I like a lot. So it's also, of course, very valid in steel. Now, let's then go to the third loop we see. It's about mechanical recycling, and it's real reuse of the chemical product without changing the chemical bond. And it's really reinserting it into the value chain a little bit earlier. Now, if you look at this one, there is a range of 19 to 51% in Europe which is being recycled. From 19 to 51. That's clear that that difference is caused by government regulation. So this one is really, yeah, so this one is really impacted by government regulation. And I think the big question mark also there, if this is really valuable without government interference. There's a big question mark there. I think the challenges we have, of course, is typically recollection of the material. The ones of Belgian citizens, just think about how we talk about PMD in Belgium already since months and years and how to do it. So it's clearly a big question mark. And also, I think if you look at what's needed, I think a continued effort in order to improve this one, this is, okay, restart again, is that more effort in R&D is needed to think already upfront on how it can be used. Okay. Everything is collapsing here, by the way. Okay. So again, three things there. I think we all know the example where bottles are in the end up in park benches, melt in park benches, thermoplastics. That's a typical example. In order to improve this one, what needs to be done is we need to have more of those cascades, natural cascades, where products get into a value chain and gets into another product. Second thing is that already at design, we should take into account where it can end up and how we can recycle it. And third, because purity is a challenge, purity of the product is a challenge, I think it's also going to be important is that the whole concept of ownership is probably might change. Maybe the product, the producer, manufacturer might also become and stay the owner, and it's all about almost like leasing products in order to guarantee the purity of the product. So I think here, in chemicals industry, is one with a lot of potential. We believe it's around 18% of the molecules, probably for the 63%, can come via this loop. Now, in steel, a bit more artificial. We're talking about reuse of coils, second choice, and so on, and use it for a lower grade. But this is already, I think, inherent at the current process, where coils, which are not okay enough, you put them on the market and you sell them and try to find a product with the right quality requirements. We're going to the fourth loop. It's about the chemical recycling, and that's really the most challenging one, we believe. It's about breaking up those large hydrocarbons into small precursors. And this happens well via catalytic cracking and plasma gasification. A lot of energy needed, very energy intensive, already said, and the feasibility and industrial scale still needs to be proven. We look probably at around 8% of this one. And this one, if we make a comparison in steel, we might refer to electrical arc furnaces. But then again, I think it's a bit an artificial comparison we have there. And the fifth one, which is a big topic, and it was already a big topic in steel for some years, of course, is the whole CO2 challenge. How to capture it. And I think where you have some examples in the steel industry, I think the challenge we see, of course, in the chemical industry is similar. It's about what's the cost of H2, hydrogen. You need to have also a source of very dense or concentrated CO2. So I think if you just look at the volumes we need in H2, I think for the 10 million tons of feedstock, we'll need, or 10 tons of those chemicals to reused, molecules to be reused, we'll need 5 million tons of H2, hydrogen. So just to show you the challenge we have, and of course affordability is going to be a big question mark. So there were 5 loops in the chemicals industry, and I think what we have heard probably in each of those loops are probably, what about the government? Government regulation might help. I think investment cost of energy is going to be important always. And I think also change of, the process itself is about design, how to, already take it, when you're designing the product, already take into account the end stage or where it might possibly end into your process. The common thread we see in those different topics. Looking at how this impacts in steel, we have the 5 loops there. And I think, loop by loop, again, loop 1 and loop 4, it's all about reusing scrap. It's very usually done in steel. I think the big question mark over time is going to be what about contaminates different types of scrap, but also over time, if electrical arc furnaces really take on in China and so on, where's scrap going to come from? We see in our other research we have done about steel in 2030, we see there's going to be scrap imbalance in a certain way, in a certain time, between China and the rest of the world. So a big question mark about scrap. I think the reuse, if we go to the second part, reuse of products. I think the problem we have there is that steel often is not a determining factor of the life cycle of a product. There's also some challenges on logistics, on labor intensity, and there also, of course, on design. You take when you design the product or the building, you already take that into account. And of course, metal fatigue is always going to be a challenge or a concern. I think the fifth one, is the CO2. Already had some extensive discussions on this one today. There's no elegant solution right now. Still some tests and quite some challenges. So if we look at steel, we see there indeed the 2 things which are, I think, probably the most valid for the industry, the reuse loop and the scrap loop. And I want to come back to the most important point, maybe at the beginning, is that, if we look at it, and the comparison we also make in the chemical industry, again, coming back to the chemical industry, where we see that there's a lot of value captured in the downstream industries. We're also looking at where we are in the steel industry. We also believe that there is a lot of value captured in the downstream industries in steel. I can give the example again of automotive and steel, how over the last years the innovation in steels in automotive has enabled automotive industry to reduce car weights, which is going to impact on CO2. Those kind of examples, I think that's going to be important. The same is that if today you build a bridge or whatever you do, you need less steel to come to the same result, is also, I think, more important factor to take into account. That a lot of those trends we see in the circular economy, because in the steel industry, a lot of these circular economy trends are already there. It's about reuse of scrap, it's about using scrap in your process, and indeed trying to improve reuse of the steel. So, summary. We need to go beyond the make, dispose industrial approach. The steel industry has circular economy as its core. It has some challenges, I believe, indeed, or some nice, I would say, ambitions with regard to CO2, which is also valid in the chemical industry. And again, I cannot stress enough the importance of innovation, because there, in our opinion, a lot of value is captured, where the focus probably is today also of the industry, and I believe is also maybe should also be. So, thank you.